talk about monolith and microservice. And as for me, like I can't discuss anything without giving a analogy. So let me give you a very small analogy to bring home the point of microservice versus monolith, and then I'll go into the technical details about it. Right. What we have here, a taco stand. A taco stand, a food stall, is one single person operated. That single person is taking care of everything: customer satisfaction, manufacturing, marketing, raw material, hygiene, then sales, then accounting. That person is taking care of everything. That's what a monolith is. Let's take this example and say, let's say we have graduated to a bigger pizza place. This is how a pizza place may look like. Now you could see there are multiple people involved. There would be a baker who would only be doing the baking stuff. He would be creating the pizza, baking, putting it into oven, getting it ready. Another person may be doing packaging. So that person is involved only on getting the pizza from oven and then packaging it to go to a destination. And if it is like a in-house dining, then probably there would be a server who would be sending or giving this pizza to the customers who are waiting on the table. So that's how what we did here. We are still serving food, but now the work has been divided. What we are seeing here, that the person who is baking pizza is completely different. He may never know that who actually ordered it. Someone who is packaging the pizza, who would never know that how much ingredients were used by the baker inside it. And somebody who is serving the pizza may never know whether it was paid by cash or whether it was paid by card. So actually what is happening here, we are dividing things and ensuring that everyone works as a single unit, but still everyone is doing their own part, right? Hope everyone is okay so far. Let's move to the little more sophisticated way of working. Let's say instead of a pizza place, we now go to a fine dine restaurant. When you go to fine dine restaurant, it would be little differently approached there, right? You would be greeted by someone in the very early. Let's say you are coming in and you would be greeted by a person. He or she would take you to a desk, ask how many people you have, like where you want to sit, a quiet place, or you are okay to sit into a crowded place, whatever the preferences is. So that person would take you to a table. Now, once you are there, afterward, what you would be having in that you would be able to see there would be multiple people. There may be a bartender, maybe there would be a person who is ensuring that you get your welcome drinks on time. There may be another person who would ensure that you get your snacks on time or you get your food served on time. So that is the different persons getting involved. Maybe bartender, maybe a server, maybe another server who is coming in. And at the back end, there is a team of chefs who are working to ensure that you get the food you ordered. Now, if I'm a chef inside the kitchen, I would never know that who actually has utilized or who actually ordered what. For me, it would be just a table number. My order would come to me as a chef and it will say, hey, table number 5 ordered XYZ, prepare XYZ, and then give it back. Simple, right? So that's how your all the work is being divided, still working as a single unit, but you are all divided and utilizing all your stuff. So yes, pizzas can help you a lot. Pizzas, if you know about pizzas, a lot of things in cloud are very simple, isn't it? Thank you, QWS. Okay, so idea here is everyone is talking to each other, but in a different way. Let me give some examples so that you could relate to how the things are working here. Now, when somebody is coming to your table to take order, they would write down that order maybe into a tablet, maybe into a notepad. And that notepad or note would be then served to the chef into the kitchen. And there also would be a master chef who would take care of who is going to prepare what. So if an order contains a soup, it contains a main course, it contains a side, maybe there are different chefs inside who would take care of it. So somebody would read that information, what is being requested, and then divide that information into different tasks and deliver it to the backend. So that's two things we are seeing here. There is a front end, there is a back end, and we do not have to worry about back end. We go to restaurant, we expect that we would be given a menu, and once we get that menu, we can go ahead and order the stuff, and based on that, we would be able to get our stuff. And we would ensure that if we are ordering something, we get the correct order. How they take care of ordering things correctly, from where they source their ingredient, I have no idea on that. And actually, as a consumer of the services, I should never be worried about it, because that is all their internal stuff and they can take care of all the stuff for them. So that's how your restaurant business may be working. right? And don't worry, I was not in restaurant business, but I like how they operate efficiently, especially the fine dine restaurant. They do things very perfectionally. So that's why I'm just taking some examples there. All right. All right, good. Now, what else? So this is just keep at back of your mind that this is what a difference between microservice and monolith may be. But now let me go to a technical context and try to understand what your microservices are or what your monolith are. So let's first talk about monolith. Can you share use case for when to use ECS or EKS? That would come, but it's not today's session. Probably we can discuss it little later. You can send me some messages and I would be happy to respond it on the chat, on the LinkedIn if required, but not today. Sorry. We can include container in some other section. Okay. So talking about what a monolith application is. Monolith is basically, it is a one large system and it is usually one code base. From very beginning, somebody started and thought, hey, this application which we want to build should be built into Java. So what we should do in that case, we should take the code base as Java and start deploying code inside it, start developing the stuff and make it like one single unit. That is what is built as a single and indivisible unit. It is everything is put together into one single unit. They are designed without modularity. There would be one code base. You would keep on checking in your code inside. You would keep on compiling the code or maybe interpreting the code, and then you would get your application, and those whole component will be deployed at once. Now, there would still be logical bifurcations that there would be a user interface. There would be some business logic who is processing the information, and there would be some data access layer who would be storing the data which you are using or storing, and that data would be probably going into a single database, and everyone has to follow from user interface to business logic. Business logic will talk to database layer, and then data access layer can talk to database. This is what a monolith application actually looks like. And all these components depend on each other for work. If any of them is not working as expected or any of them is not functioning as expected, then you won't get the output coming in, and all of them are leveraging one single source of your databases here. That's what a monolith approach is. Now, we are not trying to say that monoliths are bad. We are just saying monolith is one approach, but in some scenario it may not work. Like if I give you an example, in very early days when Amazon.com started, I'm talking about Amazon.com, not AWS. Amazon.com was initially a monolith which was on Java, and the backend database we had was Oracle, right? And we were scaling this Java application multiple times. We were making sure the database is operating as expected, but obviously it was not very efficient for long term as the business was growing. This approach was not able to serve the purpose. We were not having that type of thing. In very early days, when we started utilizing this approach, we had a 3 month release cycle. Every 3 months, there would be a code base change happening. There would be new functionality added into Amazon.com. But if I'm talking about today, every 90 second or even less than 90 second, there is a code change happening in Amazon.com without any downtime, without any problems. And that's how we are rolling out new feature to customer faster. And that was not possible into Monolith because here what is happening, there a deployment happens all at once. You could not deploy them in shorter period, and then component depend on each other for work. Now today, if you go to Amazon.com homepage, that Amazon.com probably is made up of 200 plus microservices. Maybe one microservice for your product of the day, another for your account, another for the last order you process, another for your browsing history, another for recommendation, n number of things. And that has become like a microservice driven architecture. And I'll send you some links where you could get more idea on that, how actually Amazon.com evolved. So that's what monolith is. Now, what are the challenges in this particular approach? Let's try to understand it. So monolith challenges, they are barrier to adopting new technology. Somebody start in very beginning that, hey, we are going to use Java for it, or we are going to build this application in PHP. Maybe now we have a better language or maybe we have a better front end, but we can't change it because it has been there from long time. So it is a barrier to adopting new technology. You cannot make certain changes there. Continuous deployment is difficult. If you're deploying again and again, then every component has to sync in. What about there are 4 teams working on it? 3 teams are ready with their code, but one team is still not finished. They are still waiting for the code, which means you still can't go with deployment because they are all dependent on each other. And over a period of time, your code base become larger and complex. It would be complicated to maintain it. Microservices may be difficult to scale also, because what happens if it is my monolith, monolith are difficult to scale because in monolith, I have provided some CPU or RAM or processing power to this. Now, what if I'm running a campaign and I need more processing power only for business logic? Probably it won't be happening, because when I'm adding CPU or RAM, that is happening for the whole monolith application. So that can be a little challenging to scale them, and obviously it will become difficult to maintain. There've been too much changes happening, and that's why you may find it little difficult to manage it. So that's why some monolith challenges are.